Hey friends, welcome to JD's Guidance. Friends, in this video today we are going to check this particular topic, normal distribution and risk assessment. Friends, in the previous videos we have already seen what is risk, types of risk and the statistical measure of risk, mainly the standard deviation variances. In the last video also we have seen how to calculate beta, that is the measure of systematic risk. Friends, for your ready reference, the link for those videos are there in the description box. May check those out. Coming to this topic, this is my small attempt to explain you how we can also check risk of security by referring to the normal distribution. Actually, risk is what? The variability in the return. I have an expected return in mind. To what extent this expectation may not come true or how much my expected returns will vary, that is actually the risk. I have an expectation and if it varies, it is risky, right? Now the question is with normal distribution, how we can see this. So please excuse my drawing. So, whenever it comes to normal distribution, we refer to a bell-shaped curve. So friends, initially I also had a lot of confusion about what is this curve all about. But I will help my viewers to understand it to the extent I did. So it looks like this, okay? This curve is symmetrical. What is symmetrical? Symmetrical in the sense that it is so even that if you have this curve, you will find I can split this curve in two parts equally. So if I have say 60 observations of returns, that my stock has got 60 observations, 60 returns, maybe from month 1, month 2 or year 1, year 2, I have 60 or 30 or 12 data. If I plot it, the data is normal, it will look like this. Okay, so if my all 60 is considered to be 1, suppose I have the total distributions or total data equal to 1, and if I plot it, the entire 1, it will look like this, right? So the entire portion is 1. So if the entire portion is 1, then half of it, 0.5, is in the left side and half of it, 0.5, is in the right side. Otherwise, it will not be symmetrical. If it is 0.75, 0.25, then it will be tilted towards the left. If it is 0.25 and 0.75, it will be tilted towards the right. So if it is a symmetrical distribution, it will be like this, a normal distribution. Now check, my dear friends, if I have this part as my probability values, so you will see the probabilities as we go up, it is increasing. That means if I am here, the chances of getting these values, which is very less, see, if I have these values, chances of having all these 60 observations in this part is very less because I have few observations only which is scattered in these tails. Okay, this is the left tail and this is the right tail. I have less probability of getting a value in this tail because there are less values accommodated here. There are less values accommodated here. But as I move upward, as I go up and up and up and up, more values are found. More returns I will find here. Okay, more values we will find here. Okay, but as I go down, there are less number of, suppose you consider there are 60 people who are accommodated in this house. Okay, and you are looking for someone, so you want to find out where should I look him for. Should I look him here, here, here? So I would say you look him at any zone here. There are chances less that he will be here because it's a small space, few people will only be there. He might be here, there are chances, but there are less chance that he will be here. So probabilities increases as you go upward, right? And all the values inside the curve is equal to 1. Half of it is in the left and the half of it is in the right, right? How can this help me in the risk assessment? And this center is my mean, which is also equal to the median, which is also equal to the mode. Okay, and this we call it to be mu. This value we represent it by mu, right? Now suppose an investor has an expectation that he will earn 20. Okay, and he earns exactly the expected return 20, means he is not varying, neither he is going this side means he will be earning less, this side means he will be earning more than 20. Now if he goes this side, say suppose he says what is the likelihood, I am expecting 20, but what is the likelihood that I will earn 10, means he is expecting something that side. Now he is trying to find out the probability that he will earn 10 minus, means less than this. What is the probability that he would earn more than 20, that is 40, means he is expecting this side, right? So as an investor, I am expecting this. This is my average. But what is the chance that I will get zero return, or what is the chance that I will earn negative, means losses? So this type of things may be exploited by an investor, and this normal distribution can help you. Now suppose I am saying it is 20 and I want to know what is the chance that I will earn 0. Means 20 is here in the center, and when I say 0, 0 will come in the left side, right? Because 20 is here, so 0 will be very far. I have reached 10 here, I have reached 5 here, I have reached 1 here, somewhere here. Means 0 will be here, right? So friends, this 20 I call it as, say, expected value, okay? I am calling it as x bar is equals to 20. And this 0 means what is the probability that I will get 0. So I will call it as x. Probability that I will get 0 or less than 0 means less than this, means this area I am trying to find out. What is the chance that I will be in this area given my expectation 20. So x is equals to 0. So friend, this I have a z score, okay, z value, not z score, sorry, z value. At this point, there is a z value which is equals to 0. What is z? That is not mode. Z is a value which helps us to identify the area. You will try to see this now. Okay, you will find it out now. I will try to find out if I am in the center, the z is 0. If I move to this point, what will be the value of z? So I want to find out what would be the value of z. Why I am doing? You will see it very shortly. So there is a formula. Z is equals to, you write x minus x bar divided by standard deviation. So what is my x? X is equals to 0, means probability that I will earn 0. And what is x bar? X bar is 20, that is my expected return. And suppose my standard deviation is 10. So you get minus 2 out here. That means my z value at this point is minus 2. So means when I am at this point with expectation 20, my z is 0. But when my expectation is 0, my z is minus 2. So I have covered a distance backward, means in the left side, from z0 to z minus 2. Okay, means I have covered this distance of z. Okay. Now there is a table called Z table where you can find out what is the value of area. Means this area I want to know, the probability of this, of z minus 2, and refer to the table where z is minus 2, 0 to minus 2, this distance 0. When z moves from 0 to minus 2, what is its value? So I'll just refer it in the book. So it is 0.0228. Okay, so this is the value of z for negative minus 2. Friends, in book, you can consider it to be positive also and write the value 0.228 because area cannot be negative. In some books, you will find the values given to you for negative values also. So 0.0228 is the, what does this mean? This means that when z moves from 0, it covers an area of 0.0228. That means this area is 0.0228. Now from here to here, if it is 0.0228, so if I have, but I'm interested to know 0 and less than 0, I'm interested to know this. So very logical, if whole area is 0.5 and this area is 0.228, I can just minus this to 0.5 minus 0.0228. Whatever figure comes means this stands the probability that this person will earn 0 or less than 0, right? The chances of earning 0 is 0.22. The chances of earning 0 or less than 0 is 0.5 minus 0.0228. Friends, there can be other cases also where the investor is expecting a return of 30. Suppose if it is 30, so it will be more than this side, so that means it will be here. So if it is 30, instead of 0, I will write 30. 30 minus 20 is 10. 10 divided by 10 is 1. So I will find out what is the value of z when it shifts from 0 to 1. So when it shifts from 0 to 1, you will find some value of z. So that means from here to here, this much is the distance. So what is the probability that the person will earn 30 or more than 30? Means if he is earning 30 or more than 30 means we are discovering this zone. We are trying to find out this zone. So obviously if I know what is the distance of z from 0 to 1 means I am able to know this zone. If I am able to know this zone and I know that the whole zone is 0.5, I minus this zone, I will be able to discover this zone. So friends, this is the idea of normal distribution and risk assessment. Ultimately, it tells us the key thing that is here is that if this is a normal distribution, there are less likely of happening this and this, more likely of happening these things because the probability is more for these values. Now, if an investor is interested to know what is the likeliness or probability that his earnings will be towards the left, you can easily find out with the help of Z value. If what is its probability of earning more than this, you can easily find out by this. Now, if you find the probability of earning this much is that probability and that much is that probability, based on that the investor can take decision about whether the stock is risky or less risky. Okay, so obviously when you have an expectation and if you want the earnings to be more than this, you also want to know what is my expectation is at my place, and the imagination or the probability that I will earn more, to what extent there is the chance that I will earn 30 or more than 30, and for this normal distribution comes to us as a great help. So friends, that's all about the normal distribution and risk assessment. Keep watching my videos and we will come and meet again in another video about risk return analysis. Thank you for watching. Bye-bye.